Hi friends, in this video we are discussing basic concepts of differentiation. In mathematics, differentiation is the process of finding derivatives. Okay, let's see why do we differentiate. Here you have a graph x comma. Okay, so in this graph you can see the slope of the graph, like the angle which makes with the x-axis. Here it is theta, at this point it is theta, and at this point it will be theta. That means the angle which makes the graph with x-axis is theta. So what will be the slope of the graph? As you know, slope of the graph is equal to tan theta. Okay, let's take 2 points in this graph, 1 and 2, and the coordinates is x1, y1. Here it is x2, y2. Okay, so we are going to find what is tan theta here. Tan theta is, perpendicular upon base. That means tan theta equal to, this means y2 minus y1. You might have studied in lower classes. Slope is tan theta and y2 minus y1 divided by x2 minus x1. Okay, slope of the graph is tan theta, and here it is y2 minus y1 by x2 minus x1. That is the case of a straight line. Okay, now let's move on to the next graph. It's a curve x, y. What is the, here we are also finding the slope of the curve. Okay, so what is the angle which makes with this x-axis? Like at this point, what is the tangent? It will be theta 1. The tangent makes angle with x-axis is theta 1, and here also it will be theta 2, and at this point it will be like theta 3. That means angles are varying. Angles are changing. That means slopes are also changing. According to the formula tan theta, slopes are also changing. So how do you find the slope of this curve? We are taking, as before, we are taking 2 points, 1 and 2. Here the coordinates are x1, y1, and here x2, y2. So we assume if 1 and 2 are very, very closer, the angle will be approximately equal. Like theta 1 and theta 3 will be equal if 1 and 2 are very, very closer. Not exactly at the same point, but they are tending to be very closer. Okay, so y2 minus y1 tends to 0. As 1 and 2 are very, very closer, then y2 minus y1 tends to 0. Not equal to 0, it tends to 0. Because they are not at the same point, but they are very, very closer. Then x2 minus x1 is also tending to 0. Okay, so y2 minus y1 is very small, no? Like they are at the same, not at the same point, but they are very closer. So y2 minus y1 will be very, very small, which is represented as dy. And x2 minus x1 is also again very small, it is dx. So what will be the slope? Slope is equal to tan theta according to the formula y2 minus y1 divided by x2 minus x1, which is equal to dy divided by dx. So that is the slope of the curve, and this is what we call differentiation, dy by dx. Again, we have another definition, which is it is the rate of change of a function with respect to the variable. Here you can see it is the rate of change of y with respect to x. We can have dy by dt. What it will be? Rate of change of y with respect to t, dy by dz. Then the variable will be z. We are differentiating the y with respect to z, dy by dz. So rate of change of a function with respect to a variable. In physics, you might have studied rate of change of a displacement is velocity. So again, differentiation. Rate of change of velocity is rate of change of velocity is acceleration. Okay, so you can relate it with physics also.